a very warm welcome from Talking Industry, and in particular from myself, Andy Pye. I'm consulting editor at DFA Manufacturing Media, and we publish a range of print and online publications in the automation and manufacturing sector. I'm joined today in this discussion on safety engineering and security in manufacturing by my colleague Aaron Bluchstein, and he is editor of Plant Works and Engineering and also of Smart Futures, which are two of our flagship publications. In addition to that, we have four excellent speakers from industry today. They're actually all first timers, which is unusual. So hopefully we'll be able to give them all a hard time in the chat box and ask them some testing questions. I'm sure everyone is familiar with how Zoom works, but just in case, you access the chat through the bottom of the Zoom facility. If you can't see it immediately, tick the three dots by the More button and you'll see chat. And then you can ask questions, make comments, and within reason, you can also put useful information into the chat. The one thing we ask is if you're representing a commercial organization, please don't use the chat for commercial purposes. That's limited to our speakers as one of the benefits that they get from the hard work that they're just about to start on. Safety engineering and security. Generally speaking, the future of safety engineering in manufacturing and processing now focuses around the digital, and this creates new opportunities and challenges for plant operators and enables them to enhance efficiency, increase flexibility, whilst making their plants more safe and secure. What I do is I introduce our speakers in reverse order, but having said that, we try to keep this as free-flowing and unscripted as possible. So we will take questions at any time they're relevant. But having said that, our last but not least speaker will be Mark Staples, who's UK Sales and Services Manager from Euchner UK Limited. And he'll be talking about emerging trends in machinery safety and how to integrate technology into both new and existing assets. Before him, we'll have Ian Holland, who's the Managing Director of Dold UK. He'll be talking about TÜV certified systems for safety requirements and how they can aid flexibility in safeguarding hazardous areas where things like conventional cable runs would struggle. Moving up again, second in our list will be Luke Orehawa, who's the Safety Engineering Manager of Control Techniques. We've had a number of speakers from Control Techniques and their holding company, Nidec, in the past, but this is Luke's first time. He'll be talking about reducing complexities in wiring and installation, which is very relevant in the drives that they manufacture, and how to maintain functional safety integrity and how to utilize safety logic for reduced security risks. And that leads me to our first speaker, who will head off as soon as I've introduced him, and he is Oral Buda, and he's Director of Product Management Factory Automation Systems at Hans Türk, and he's going to talk on cybersecurity and automation and how the industrial Internet of Things is leading to a blurring between IT and OT, which will be, I think, quite a common theme on today's presentation. So with that, no further ado, I'll hand over to you, Oral.
Thanks, Andy. Yeah, welcome to our talk. And as said, my name is Oral Buda. I work at Türk. I'm the Director of the Product Management Division for Factory Automation Systems. And that is systems technology coming from Türk. So Türk used to be a vendor of components, of sensors, individual products. And we started pretty early, around 2000, to transit from a vendor of components to a solution provider, system provider. And all of that is coming from my division. So I would like to not all of that, but many of that. So it starts with remote IOs that you use in machines to interface with sensors and actuators, which nowadays run on industrial Ethernet. We have safety remote IOs, but we even have edge controllers ranging up to our own specific cloud service. But we also have devices to connect your systems, not just to PLCs, but to other cloud services or MES systems. And that underlines pretty much what we see and what is referring to the Internet of Things or industrial Internet of Things, that there is a lot of communication going on. We have a lot of Ethernet already in our installations. More or less any modern installation has at the core industrial Ethernet. And we nowadays have integrated systems. First of all, even modern safety systems run on the Ethernet or Wi-Fi infrastructure, as we are going to learn. And the communication passes are more diverse. So traditional automation networks used to have sensors and actuators being connected to like remote IOs and then straight communicate back and forth with the PLC, and that were like closed systems. But now everything is opening up. It's communicating not just to the PLC, but to SCADA, MES, and even cloud systems. And there are many points for intruders to attack your system. So new threats are coming up. And what we see right now is, to my mind, we're still at an early stage of getting the awareness that security is becoming a more and more an issue. So early attacks have happened years ago, but still nowadays I see companies that are very aware of cybersecurity in industrial networks, and I see companies that are not that aware of it. And the interesting fact is that today I would say that 90% of my customers, when they have their machine up and running, the installation approved, and the machine is online or the factory is online, they're pretty glad and happy. And one thing that most of them really don't like is to change anything about the system. They don't like to do firmware updates and stuff. And that is where the game-changing thing is just at an early stage. In a couple of years, we will see systems that need to get firmware patches out of security reasons, just like our IT infrastructure is patched nearly every day or every week. And that is kind of a game changer. And adding that to safety systems is not just from an acceptance or awareness point of view for our customers, and interesting challenge that we definitely need to overcome. It's from an approval and certification and standardization point of view, not yet finally resolved. Standards are working on it, but it's still a challenge to overcome to have standards that allow for security patches even in safety systems. And nowadays, to round that up, what you do today is you need external measures to protect your system for from cyber attacks, because at least at the lowest level in industrial automation networks, the core protocols are intrinsically not secure, excuse me. I'm from Germany. I told that in the pre-meeting. Safety and security in Germany are literally the same word with different meanings. So not secure. So like Profinet today is not very secure. They're working on adding security to the specification. OPC UA is already having security. Many others don't have. And that's another change in the system that we see. In 5 to 10 years, I'm pretty sure everything is secure. And secure doesn't mean it is secure today. The system has to be monitored, observed. Vulnerabilities have to be detected and have to be fixed and patched. And that will be a big change of what we saw in the past compared to what we saw in the past. You're still
That's excellent. Thank you, Oral. That raises a number of things I think that we should perhaps quickly look at now. I'll ask a couple of questions, but we do encourage our registrants to put their own questions into the chat as well, because we want to hear from you. So while you're warming up, do you find, I mean, you mentioned awareness. Do you find that is a function of company size? I mean, are small companies less likely to be aware than large ones, for example, or is there no obvious correlation.
Yeah, to a certain extent, but not necessarily. I mean, there are even startups that are specializing on adding cybersecurity mitigation strategies, especially to industrial Ethernet networks. So those companies are extremely small. But the average machine builder, to my mind, does not have the same capacity as a car manufacturer. So a car manufacturer is very well aware of how much damage cyber attack may cause, and they usually take all measures to protect and secure the installations, while a common machine builder may not have the same awareness of security. I guess the term security is nowadays, it is available, and people at least heard about it. But awareness really means that every developer and everything that I engineer around my system has security. I have security on my mind when I do things. And that kind of awareness is, I would say, in many companies, not yet there.
Okay, but maybe in what, 5-10 years time that may change.
Absolutely. It's a necessary evil. So it does not add a lot to the function of the machine, but we need it.
Okay, thank you very much for that. We have had our first question come in, and I'm going to read it out, but not ask for any answers yet, so that all of our speakers can have a time to think about it. And it says, is there a standardized security model for factory automation systems, segregation, endpoint hardening, DMZs, etc.? So think about that, because I'm going to ask everybody for their opinion on that. But first of all, I'm going to ask Luke to present, because what he has to say, I think, is very much related and relevant to Oral's presentation as well. So over to you, Luke.
Okay, thanks, Andy. So my name's Luke Hauer. I work for Control Techniques. We're known for our green drives, green in energy, but green in colour. But also we are known for our integration with factory automation systems. We've been doing field bus technology and support the main front runners for quite a long time now, and introduced our first industrial Ethernet system in 2005. We haven't stopped there, and we've expanded to support the main industrial Ethernet protocols because the demand is there. And that's because everybody wants to make their system simpler and cheaper. And having one cable rather than many cable does that. Every cable you introduce into a system, there is time in that panel build. And that's where most of the complexities come and the mistakes. So if we can reduce the number of cables, we're on to a winner. Functional safety traditionally requires more stringent cabling measures for shielding, for grounding, for testing. Typically, there's double the number of cables. So if we can remove those cables and make those systems simpler, we actually increase the robustness of the system. And that's where functionally safe protocols have come into play. To name a few, we've got the FSOE for EtherCAT, we've got SIP Safety for Ethernet IP, ProfiSafe for Profinet. I mean, they're the front runners that we're seeing and that are widely supported around the globe. But these protocols allow a secure and high integrity of data between the sender and receiver. Now, typically that sender is the PLC, if it's the control information, and receiver being the sensor. But really it's about safe data exchange. If you can reduce the number of wires, you're reducing the number of the amount of space you need in that cabinet, and therefore the cost of the system. So this move and trend towards safe protocols running in the system has its advantages that everybody wants to jump on board with. And now you can say, well, our safe network can be converged with the non-safe network for control and status monitoring. So we now have one network running SIP Safety and Ethernet IP, for example. Ethernet IP running the control and status, and SIP Safety, the safety information to be exchanged with the controller. And we can take those advantages even further. And this is the trend we're seeing now when we start integrating the IT system, because we can actually start selling extra services which improve the overall system efficiency and effectiveness. So no longer are maintenance visits periodic, but they're when they're required, and even better, before they're required. So we're sending that data up through the cloud mechanisms to be monitored by service providers to say, oh, we're very near a service visit to go and exchange this, this component on the machine. So it benefits all, but that convergence between IT and the operational technologies, such as the industrial control systems, quite recently has proven difficult. In 2016, there was an attack named Crash Override on the Ukrainian power grid. This attack was the first industrial control system attack since Stuxnet, which we saw in 2010. That was pretty quickly followed up in 2017 by the world's first cyber attack on a safety control system. So we saw, it's named Triton or Trisys, both terms are used, named because it was an attack on a Schneider PLC, the Triconics, the safety controller. And in both cases, with the Ukrainian power grid and the Triton attack, the mechanism of infection was through the IT system, typically through email. So the engineers' PCs would be infected via an email route, and then the attack is able to traverse into the industrial control system, and quite worryingly in 2017 into the SIS, the safety control system. We have placed in the chat a couple of links to the articles to back up these stories, because there's loads of interesting features in there. One point that Aurel brought up was the resistance to maintain firmware updates, or even worse, to downgrade firmware from the latest that's been provided. And in the 2016 Crash Override attack, through investigation, they found that a number of the components, which it wasn't one targeted, it was many targeted for the full successful attack, but they've had updates in the field from the vendors for up to a year before the attack. And they were there, they could have been updated. The attack or the scale of the attack could have been reduced or removed had a security practice of keeping things up to date been implemented in that factory. So whilst we're seeing IT and OT convergence happening, and there's lots of benefits to having that single network, there is also the downside that we're now opening ourselves up for an extra attack vector. And when we start looking into cybersecurity, there's a really strong common theme on where the weak link is in the system. And it's us. It is the human beings. It's us operating the machines. It's us as the engineers. It's us as the staff within the system and the company. We are the weak link. We're the ones who click on the links in the email. We're the ones who download a file and put it on a USB stick into the industrial control system. And so we can talk about industrial control measures, and back to the question, there's lots of mitigations listed there, such as demilitarized zones and endpoint hardening, but on their own, they're not the answer, because what we need is a secure process for managing that machine's life cycle, which hasn't been mentioned so far in this discussion, but there's the IEC 62443, a cybersecurity for industrial control systems standard. It is a standard that's evolving, but the minimum you could do is look at part 2, 2.3, which is risk assessment, because that's all it is. We're all interested in functional safety here on this call. So we understand the nature of assess the risk and mitigate the risk. And we're just doing that, but thinking about cybersecurity and not just human lives. And if we don't do it, then human lives will be at risk, which, you know, it's providing that structure, and that's new to us. As Aurel said, you know, it's a new thing. People want to stay safe with, oh, I know this, I know it's going to work. This firmware is tried and tested. We've approved it in the factory, but we've got to move to a different model where we start thinking about, if I don't update this, if I don't maintain it, what could happen? And that might affect our certification. You know, our certification for a product needs to be renewed every 5 years. So there's already a 5-year period, but would you really want a known issue being globally known for 5 years and you not fixing it because you didn't do anything about it? Which I think is the crux of the problem that we've got ahead of us.
Thank you, Luke. That's really good. We will now open this up, and I mean, my question, which I'm going to ask everybody, perhaps starting with Mark, is why is the factory automation side the weak link? I mean, you said it's people, which I accept, but you know, we don't hear, or do we, so many problems from the business side, the finance side. What is it about factory automation that should make us so concerned?
I think Luke mentioned that in his previous conversation around this IT-OT convergence, and I think genuinely most IT teams aren't used to or aware of the factory installations. You know, they're very familiar with the IT layer and they're very familiar with all of the office type equipment, but maybe not so familiar when it comes to the operational, the OT layer. And I think one key area to address that is through education, you know, because we see more connected devices now. We want more automation and we want more networkable devices that sit on Ethernet, Ethernet IP, Profinet, etc. And potentially those are open to attacks. You know, if we look at where attacks have got into businesses, it's generally, you know, it's snuck in by the OT level. So for me, I think on those factory installations where we've got this network around the factories, that, you know, IT, OT, they are leveling up more now, but are they aware? And is there a need and a space for education with the IT teams?
Yes, I mean, that's a very important point. I mean, do you as a company offer any training in that sort of area?
So we tend to focus on safety technology, and alongside a lot of the standards and regulations training we do some product training. Particularly, we do a lot of our products which are networkable. So we do sit on Profinet, EtherCAT, Ethernet IP. So part of that product training is to make people aware of, think about your networks, think about the hardened network switches or putting a demarcation zone in place. So we do have a real cybersecurity slant on some of our more product technologies, and particularly our controllers as well, because, you know, they too can sit on an Ethernet network. So, and we're passionate about that because, as Luke quite rightly said, potentially we are putting people in harm's way, you know, by people attacking these systems and getting them to malfunction in a really unsafe way.
Great. So training courses part of the solution.
Yeah, education, training and education.
Yeah.
Big thing.
Ian, what's your take on this?
So I think you mentioned a point earlier, Andy, that we're not affected in the finance markets. We're not affected in Ethernet and IT generally, and that's because IT engineers are very diligent in, first of all, what they allow access to the system through, and secondly, how they segregate individual parts of the system. So, you know, people aren't allowed to walk into server rooms, that kind of level of security. Now, I think there's no such thing as an unhackable network. If there is the want, the desire, the amount of money invested in ethical hacking to circumvent any system, then someone will get through whatever penetration aversion techniques you use. I think really that Ethernet in itself, in the way in which it's structured, has lots of holes in it. Anywhere up and down a 7-layer OSI model, you are able to intervene and capture packets, pretend to be someone else, tell a network that you are the fastest way to the internet, and all of the traffic on the network goes to you. So, I mean, all of these tricks have been around for years and years, and you know, people have been able to do it for a long time. So I think really, for me, the best way to avoid Ethernet degradation, as far as hackers is concerned, is to properly segregate it. So the way I mentioned earlier in how those who want to gain access can't with the financial industry, for example, is first of all, there's no remote access via USB, via Bluetooth, or any kind of interaction with the individual nodes, unless you're authorized. And secondly, the network becomes very secure. And if you have the right level of network sniffing involved, it will stop or give notice of anyone who shouldn't be there, because all of the network sniffing software knows the structure of the network. As soon as you say I'm a router and I'm the fastest way to the internet, the network sniffing software says, actually, I don't know who you are, and no, you're not. So I think prevention and also detection is, going forward, the best way to cure these kind of issues.
I do think, Ian, sorry, Andy.
Go ahead.
Elaborate on that. I do think myself that we have to ask what we're trying to achieve. And when we had a single wire, that was simple. We want to move a signal to achieve something, whether it's to turn something on or off. In the digital world, we could view that as moving data values across a network to convey the same meaning. And to me, I see the problem as two-pronged, is data integrity and system robustness. Data integrity, can we trust that data? Now that comes down to, can we trust the source of the data and how it's transited to us? And then system robustness comes down to the networking, and as you said, with Ethernet, there's loads of robustness issues we can foresee. But if we were to look 10 years ago, would we be thinking now that a hard disk is almost redundant as a backup storage device in our systems? You know, we just move data around. It syncs to our backup storage in the cloud. With our safety control systems, I think we'll stop thinking about a protocol and a network, and we'll start thinking about a source of the data and where it's transiting finally to, and how it's going to be utilized. And then we have to worry about the robustness of that along the way. So, well, I've got a robust solution because I'm using this protocol. It's got these security measures. I've locked down this route. It's got the most up-to-date firmware. And that segregation from how it's transiting to what it's transiting, that's when we're going to start seeing, right, now we can do safe systems, no matter how it's all connected up. And we just worry about what we need to make that system robust.
Oral, do you have a view on the discussion as it's developing now?
Yeah, absolutely. So first of all, you asked why factory automation is not that aware of security compared to maybe financial systems or others. I think that the threat for financial systems is pretty big, but latest with the internet, everything was connected, and that's why the awareness and the mechanisms on IT levels are simply available and are kind of mandatory requested. While factory automation, if you look at the history of where we come from, were integrated proprietary protocols, so based not even on Ethernet, so they were safe in their own fashion because they weren't connected to something else. And that is what we have to get out of our minds. And it began with industrial Ethernet on the top levels, and now it's even moving down to the lowest levels, even to sensors and actuators. And the first big challenge was price performance ratio. So if you add security to the lowest levels, those items, the devices will get more expensive. And technology is just coming at us that will allow to add security to the lower levels. And standards are preparing for that. Profinet, Ethernet IP, and OPC UA. But today, I'm completely with Ian. You have to segregate your networks, separate your networks, and we give trainings on that as well. We are not yet in a position where I would say Turk is an expert on cybersecurity, but using firewalls, using NAT, restricting access to different zones in your facilities, and separate your networks for reasons of net load and security are definitely the things you want to do. And the standards are highlighting that. Even Profinet and Ethernet IP have security guidelines where they definitely refer to those things. And they add that this is the process that has to be audited every once in a while. And in addition to that, they refer to, it's not just about technology and communication, it's about people as well, as Luke said. If somebody comes into your facility, a service engineer from a third-party company, and has a Windows XP laptop that has never been updated, so that may have been the root cause for Stuxnet. So it's not yet 100% sure, but that's an issue as well. On the other hand, which is a little bit contrary to what Ian said, is why are we connecting those things? What are we doing? What is industrial Internet of Things? We are digitizing what we offer. So digital services is what all of us are working on. Even a supplier of a simple sensor, of a component, has the vision of adding digital services around it, digital twins and stuff. So we have communication and we want to add services. And that is, to a certain extent, is in conflict with what we have today. So if we protect everything and exclude it from communication, we cannot add that digital services. And that is the challenge I see for the next 5 to 10 years. Enable the connectivity. And as Luke said, sync and source must be safe and secure, and the resilience must be there, while at the same time be secure while offering those digital services that all of us are looking for to do in the future. And that is a big thing. And that is what we care a lot about at Turk, and try to, at least set the way to be able to offer all of that in the upcoming years.
Thank you. Mark, I see that your colleague David has put in a link to an infographic on 10 steps to cybersecurity, which I wondered if you might just like to quickly summarize what that has to say, and also reflect on the conflict between the need to segregate and the need to communicate. You know, I mean, I know that, for example, Control Technique's latest drive, you've got an app that you can program it, you know, through near field communication, and without needing to go into the security issues of that, which I don't think are particularly great. It's an example of how we need to communicate rather than segregate. So is there like a conflict there that we kind of need to address?
Yeah, and it was mentioned earlier, you know, and a key thing is why is there a need to do this? And as Aurel mentioned, because people want, there's a thirst for this level of automation and the benefits of this. But, you know, why are we doing this? And, you know, what is the risk to an organization by having this approach? And, you know, doing that risk assessment, that risk analysis, it's, you know, we're all on here today to talk about functional safety. So that's really at the root of everything. So, you know, we look at things at Euchner, what's the risk? Let's evaluate the risk and make steps from there. So that when you look at that model, the 10 steps, you know, one of the big steps is risk management. You know, look at that risk. What's the a risk to your data? What's the risk of not doing that, you know, or doing it correctly? But then, you know, how do you keep that data secure? A lot of the stuff now is posted on the cloud. Do we consider what data we actually generate, and where does that go? You know, and I think when we're looking at putting everything onto this common network, and we have to, as Ian mentioned, we have to separate the safety, because it is, you know, there's a risk to life and to people's health and safety there. That, you know, where does this data go? Do we know? Do we have control of all of the data points? So, you know, that 10-point model is really worthwhile considering when you're looking at making these steps down this pathway.
Okay, we got a couple more questions come in, and one of them is very much central to this argument. So we'll take that first, and we'll just circulate our speakers. And then we've got another one that's come in about wireless safety. So I'm going to pass that to Ian and then lead into his presentation. So the first question, and we'll ask everybody's view, and it's, where does IT and OT split, if at all? And it says, for example, we're implementing a new OT network. IT are taking an interest in everything with an IP address, PLC drives, etc. His view is that maybe IT should not come beyond the DMZ. Do we think that's a reasonable strategy? Let me ask Luke first, and then we'll go around.
Yeah, okay, thanks for that. I mean, here's the thing. It's a risk assessment. Your machine, we need to provide a security risk assessment as well as a safety risk assessment. And so why would we put our hands over our ears and exclude voices in that risk assessment? Let's bring everyone into the fold. IT, security, we can learn a lot from them in the OT sector, and equally we could be informing them about our machines, our technologies, and they might learn something. Quite recently, and this is a research only project, but some researchers have turned a PLC into a Trojan, into an attack vector. They've put some malware on the PLC, and they've tricked engineers into coming and connecting to the PLC by doing fake alarms. So you want to see what the alarm is, the engineer connects to that PLC, and at that point, the engineer's PC is infected. That engineer's PC is also connected via wireless to the IT infrastructure. So if IT were not involved in the conversation of that risk assessment, they would be unknown to them that this was a possible attack route into their system. And it might actually be the intention of the attackers to access the IT system and not the OT system. And they're using the OT because it is not secure, because a thorough risk assessment hadn't been performed with the associated mitigations. So I think from my point of view, bring them in, let's get a proper conversation on the table as to, well, this is what our systems look like. These are the type of devices we're in. What can we learn? What would be possible risks to us as a business? Because that's fundamentally where we're going. We want to, from a functional safety point of view, we care about the human life. But at the bottom line, we're protecting the business, and we're protecting the business from cost and loss of life.
Thank you, Luke. I think that's a very good point. Mark, would you agree with that? Bring everybody in, and everybody talks about the issue.
So just a quick one. I think just to answer Alistair's question as well, IT need to be involved in all of these conversations, because, you know, we hear instances of, you know, there was a particular heavy industry incidents that we were aware of where they put their own 5G broadband router at the side of the automation to gain remote access, you know, and the IT layer was completely unaware of this connection point. So, you know, it's vital that the IT teams are on the same level as the OT teams, because there is no split. You know, it's all Ethernet, and that's how people perceive it. So bringing those IT teams into the OT technology discussions is a real vital step forward, because people will put those devices in place to make their connection easier, or whatever it is that they're struggling with. And if that's under the radar, that's a potential threat and risk to that organisation.
Yeah, or just a comment from you on that as well. And is there a cultural difficulty between bringing together IT and OT teams, or should it be a very straightforward thing to do?
There is, so, but it depends on the company. So I had a lot of conversations with customers, OT, and sometimes IT. Most of the time we talk to OT, but IT as well. And I can state what Mark said is true. I saw OT people adding LTE routers to get remote access to their machines without involving IT at all. Actually, intentionally not involving IT, and that would be my first reply. If you try to promote a hard cut between IT and OT, you will see strange things over time, and those are not good things. So I'm absolutely with Luke and Mark. They have to talk. They should talk, and it may feel uncomfortable at first, but over time, talking always helps. So that they will get along, and it's something you have to overcome. And looking at this question now, if today the requirements are not that any part of this OT network needs to have remote access or needs to have additional services, and for instance, automatic firmware updates just for security patches. What I see in this question is, rather not. But will this be the same requirement in 5 to 10 years? I don't think so. And that is something, that is a change of mind. It may be perfectly fine, even if you talk with IT and OT. If they talk, they may come to the conclusion that the OT network does not need any kind of internet access or anything else. So separate it, put it in a DMZ, and good is. You're good to go for today. But will that be the infrastructure that will be requested in 5 to 10 years? I'm not sure. So I recommend to at least look at what's coming and prepare a little bit for the upcoming years.
Thank you.
Can I just
yes, do Aaron, please.
Just a quick question. Do you think, this is to everyone, I suppose, do you think that when you look at IT and OT, that the actual problem regarding cybersecurity as an issue is actually not understood by either? That within many facilities, the IT departments don't actually have a sufficient understanding of cybersecurity. I was speaking with a cybersecurity expert about a couple of months ago, and he said that when he went into companies to sort out their issues, when he spoke to the IT, they had a very basic understanding. This was from quite a large company. So you do wonder whether the actual knowledge within organizations, that maybe they need to actually outsource or to have cybersecurity experts in addition to the running alongside the IT/OT.
That's a great point.
Who wants to handle that one? Yeah. Go on.
I think that's a great point, Aaron. And depending on, I guess, the nature of the business that the IT are involved in, they may or may not be aware. I should imagine they're very aware in the banking industry. But when you get into more industrial environments, then to answer your question, I don't believe they are. I did a lot of work previously with cybersecurity prior to joining Euchner. And just education, the simple things, passing USB sticks around the office and the way that bugs and viruses can get into the system. But also, getting those IT teams to be really aware of OT systems, because what's the impact if it takes 500 milliseconds for me to send a Word document from my desktop to another desktop? But if you're looking at an industrial network and these things are connected that way, it can have a real impact if you hit an emergency stop and it takes 2 seconds for the machine to stop because there's a bug or a virus in the system. That can have a real impact on health and safety and life. So there is a lot more work to be done, in my view, within the IT side around cybersecurity.
Anyone else want to comment on Aaron's point?
I think we can learn, basically, in the functional safety world, when we're talking about derivatives from IECs 61508, something like that, where the framework demands competent team members, competent persons. Now, the standard, which again, functional safety is really bridged underpinning on this standard, also highlights a security risk assessment should be performed if it's deemed that it's required. Well, I think now we should just say, yes, it should be performed. Whether there's any outcomes that you have to mitigate is something else. So we at the OT layer, we have this sort of structure in place where we have competent people. And if they're not competent, we get competent people, or we train them to be competent. In the IT, I'm not saying they're incompetent, but they might be not as competent in dealing with the scenarios that the OT network offers. And so what we really need to do is build that secure team, that cybersecurity team who are going to look at the IT and OT and run a competence assessment on those members and make sure we got competence within that team. And if we haven't, we do have to outsource it. Why would we not go and seek advice if we need it?
Well, I suppose one of the reasons was that the IT, they had a lot of kickback from the IT department who said, oh, you know, don't you think we know what we're talking about? That kind of that's unfortunately it's human nature.
Yeah,
you are going to get that in some companies that type of response, and it's how they can work together. I suppose how you overcome that for the greater good.
Yeah, and that is where there's parallels here to the medical industry. You know, to doctors who are put on a pinnacle as being authoritarians. They know what they're talking about. They're doctors. You know, they're going to make me right, and they are human. And so one doctor is not the same as another doctor, but collectively you put them together and just worry about, are we doing the right thing? They'll probably come up with what they know at that point to be the best solution. And so we should get out of this culture of course I know what I'm on about, that's my job, and more get into the point of view of what's the risks. You know, do we know enough? If we don't, let's go find out. Let's pull people in who can help us and worry about the mitigations. And it's that process and building a culture of cybersecurity is embedded in what we do to protect our business that we have to develop over the next, 5-10 years.
And the simplest assessment that you can run today is, do I have somebody who feels responsible for security at all, being it in IT or OT? So of course there are definitely companies that have IT stuff, but none of them is really feeling responsible for security. And the 62443, for instance, if you really want to approve your company or products, certify against that standard, there's one thing that you need at least to have one assigned security officer who is usually it's not mandatory, but would sit in your quality team. And if you don't have that at all, whether in IT or OT, yeah, it's time to think about it, and then pull in people, as Luke said, and get some consultants in and try to get that knowledge and awareness for security. So that's potentially the first step where many companies are right now sitting it.
Do you think that's why the finance sector is so successful at cyber attack prevention? Is that they have taken it that one step further, whereas perhaps in the industrial environment, because obviously it's money, that they've ensured that this is not going to be a problem, whereas perhaps the industrial sector hasn't gone down that route.
I think there, Aaron, is an interesting point that OT and IT are traditionally governed by two different parts of an IT organisation, and only recently have I seen OT managers' jobs who would normally report into the chief IT officer within a business. The thing really that I think we're all overlooking there is we're thinking big. So if it's a large canning plant or an aggregate plant with a big, huge, great conveyor belt, those kind of places are going to be nearer the replication of a kind of structure within the IT and OT functionality to be able to put that together and employ someone specifically to look after their OT equipment. Whereas if it's a small business with maybe 2 or 3 machines, you know, it's quite possible that there might be one guy who's an expert, but he's an expert at IP addressing computers or running a virus scan or updating Microsoft, but not necessarily an expert on OT. So I think what we need to look at going forward is, yes, for those big companies, it's not going to be a problem, but for the lower, the middle, even the middle end, you know, the middle and smaller enterprises, how do we deal with those guys? Because they won't be able to afford an expertise of an OT officer to look at integration with IT and demarcation and segregation, but they will be subject to the same issues of cyber attack. So, you know, maybe there is a standard or something that needs to be done further down the line to cope with those kind of installations where they're a lot smaller.
Okay, I think in the interest of time, it's probably now opportune to move to Ian's presentation, and I'll throw him a curveball as well, which is perhaps he can include some discussion about one of the questions we've had in, which is that there is a large pull from industry to have wireless safety, and currently there's lots of research going into this. So if you can take that into your presentation, and then we'll have a quick discussion about that point.
Okay, yeah. So
Floor is yours, Ian.
Thanks very much. Thanks, Andy. So I decided to field my synopsis based on I was appearing at the Drives and Control show. So my stand's behind me, you can see that. We had ever such a lot of customers, new customers, colleagues, machine manufacturers come and ask me, we didn't know that you did wireless safety. So I chose the subject to discuss today because of that. So, you know, there is a large pull from industry to have wireless safety. We've been doing it for a couple of years, but nobody knows we've been doing it for a couple of years. Now, our wireless safety has been developed with initially specific requirements used as the foundation, but we found that because we don't use any known protocols, the bespoke protocols in our wireless safety, it's almost impossible to hack. The only part you can hack really is feeding in, feeding out. So we use Ethernet and Profibus, and we can connect to a whole range of different products, but they're pretty much just for reporting. So the functional part of the safety is secure 433 megahertz, no cables, 800 meters. So, you know, in most installations, you can't run safety 800 meters. And you know, you need to have a field kind of survey first to make sure that there's no reinforcing rods within concrete, and that 15 levels of racking don't cut the functionality out. But wireless safety does already exist. We sell a lot of it in the UK, but I think probably if you look at our competitors, it's a lead on to using Ethernet, which I don't think we should, because like I said earlier, it has got a lot of holes. So one way to stop the hacking is to not allow people to have access to it by not telling them the protocol that it's running on. Pretty much. Now, the type of products that I've looked at from other people tend to use a lot of converters to go between one particular format to another. So they're not necessarily wireless, they're wired using a non-safe wireless link. we spoke, I think Luke spoke earlier about the time it takes for something to get from A to B. It might be you, Mark, can't remember. In all of our wireless safety, we fail safe. So in the event that the signal disappears, or somebody tries to flood the area with 433 megahertz being louder than the transmitter or the receiver, the devices that are being controlled by a group controller just simply turn themselves off until that interference has gone away, and then you just restart the whole process again. And the products in which I'm talking about are already in use in places like Ocado and Amazon to run their big robotic automated picking machines, you know, the AGVs. That's pretty much the level of inquiries I get all the time. You know, machines that transfer batteries from a flat one to a full one, all completely automated. So, you know, I think if you look at the kind of environments that we're being used in, they're very rough environments. So you want to be able to stop locally, you want to be able to stop remotely, but not only stop. There is, because we have a secure two-way, two-channel wireless event occurring, it's only a very small step to go from right to left with just general signals. You know, so they don't have to be safe. One of the products I'm thinking of has 8 channels. So not only can you stop when required from both ends, you can also indicate when something's running out of fuel, or the water level's low, or the temperature in which it's operating is not to the peak function. And all of that stuff, of course, at both ends can then be relayed via whichever bus you choose and into your PLC. I think really the best way to try and envisage it as well is we had a project with a blast freezer, massive blast freezer, where man was able to go inside, and that environment, because it went down to -50, wouldn't handle any e-stop. You press an e-stop and it breaks into a million bits. The cable behind is too brittle. The way we solved that was a wireless e-stop, much the same looking as the function you would have for a crane with up, down, right, left, etc. But the men going onto the site lifted the e-stop out of a cradle, took it with them in their hand, and obviously the ambient temperature, it's not been down that low. If there's an issue and something runs and they need to stop it, they've got it in their hand, they press a button and it stops. I think functional wireless safety under the right environment is definitely the way that the industry is going.
You are muted. Yes, excellent. Thank you, Ian. And that's a really interesting discussion point, which I think in the interest of time, I'd like to take Mark's presentation next, and then we can come back to a general discussion on wireless safety issues, and then leading into, if we have any time left, the relationship between safety and security, which is sort of quite a philosophical area, I guess. So in that context, if I could ask Mark now to talk on his points of emerging trends of machinery safety, which may well include some mention of wireless, and how to integrate technology into both new and legacy assets.
Yeah, thanks, Andy. So my name's Mark Staples. I work for Euchner. We're a machine safety specialist, German-based machine safety specialist. So I'm here to talk today really about how we can embrace new technology, and I think it's a great discussion piece around the connectivity of devices, more networking, more need for automation, but then the risks and challenges that brings, particularly with cybersecurity. So I'm going to bring that down to a level, but then reach up slightly as I go along. So so we see in Euchner a real trend to go towards more networking of devices. So we've already mentioned networking protocols such as EtherCAT, Profinet, and Ethernet IP. But we see a real thirst for those non-safety networks such as IO-Link that can bring real key data out of our safety devices from an operational point of view, alongside the safety functions as well. So how many times a product's been operated, how hot is the product, so what temperature is it running at, you know, what serial number, and then even things like, you know, the actuator information regarding the switch. And all of that technology really is pulled together with a lot of RFID devices. So that non-contact, that actuator paired to the switch is almost commonplace now. And Euchner are really in a good place to look at that type of approaches, because we pioneered RFID technology into safety devices back in 1998. So we've got a lot of history and knowledge and experience of doing that. So and when we look at some of the solutions today, particularly in certain industries where lockout tagout is widely used, and it's a good initiative and it's a great technology, but does it lend itself really to today's environment? And when we talk about today's environment, we're talking about those short-term interventions where people are motivated to either abuse or circumnavigate lockout, tagout type technologies, or not even use it at all, because the need to just quickly wipe a surface down or to straighten a piece of work up, the time taken to put your padlocks on and then going back to the main isolator in the panel, often makes people not put those lockout, tagout procedures in place. So what we're looking at now is overlaying that with some RFID technology, with an RFID key, which is used in conjunction with safety devices to give a safer environment for those short-term interventions that complement other safety functions on the machine. So rather than having to go and get a padlock and isolate, you put your key into a reader, which is something like this. So you pop your key into the reader, and the control on the machine can be done in a safe manner, or even using in conjunction with two. You might take the main one out to stop the machine, but then put it into another RFID reader within the machine for an operation to be done at a safe speed, because it might not necessarily be wise to remove all sources of energy, even though the standards do say so. So we might need some maintenance operation that needs some power or some creep speed. So, you know, when we look at emerging technologies, those types of technologies really are something that we embrace. But the dilemma is, how do you introduce those into old machines? You know, it's quite an investment. Often there's a new control system required, but you know, that does cause a dilemma. But there was a key point made earlier about that risk assessment, you know, and the need to, why should we do this and why do we need to do this? So we take it back. What's the issue? Are people motivating them, or is there a motivation to defeat these interlocks? Is lockout, tagout the right type of technology for this type of intervention? A way forwards. Now on new machines, that's I guess relatively simple. Martin, there was a chap called Martin Kidman in the chat that made reference to a very good technical report, 2T100, which looks at gives guidance to manufacturers of new machines when they're looking at putting connected or networkable products on there, and it looks at cybersecurity. But the key thing there is that that's used in relationship with the risk assessment process under 12100. So, you know, new machines, it's easy to do. Let's use that those approaches and the standards that are there. But there are some real benefits to be had by having this new technology around keeping people safe, because if something becomes a real burden to do, then it will motivate people to not put those measures in place and not put the padlocks in place, and it's putting people at risk. So, you know, from emerging trend and technology, there's a real opportunity now to utilize more of this technology, because we can sit the RFID device, which is ideal for short-term interventions, or gives a level of go, no-go type operation on a network, you know, so we can sit that as a device on a Profinet network in conjunction with other networkable devices. So we've got control, but we've also got the data. And we can use that data in a really positive way. You know, why is someone opening and closing or having access to that particular part of the machine on such a frequent basis? So that data can be used in a real proactive way on the other side. So we see a lot of this stuff going on. We've got lots of discussions going on at the moment with various customers about these RFID type key in pocket systems, as they're often referred to. And we think it's a real technology change and a real benefit going forwards.
Thank you very much, Mark. The point that you made, which kind of resonated with me, was the different challenges between new and what we call legacy machines, don't we? And quite amusingly, a couple of Fridays ago, I listened to a presentation, and Aaron did too, actually, about why our level of automation in the UK is so poor relative to many other countries. And one of the reasons put forward, and Oral will find this quite interesting, is that we're very proud of keeping our old machines running, whereas in Germany they're very proud of their new machines, and that was kind of a cultural difference. And I'm sure I'm guilty, because I kept a Ford Anglia running for 35 years, so maybe it's just in our DNA. But you know, what do you see as the specific challenges, Mark, of introducing the new technologies to older equipment?
Well, I guess you just hit one of the nails on the head there, Andy. You know, we do rely upon, and we have done for many years, traditional hardwired systems. So if you look inside the control system of most machines, you'll find a hardwired safety relay or safety related control system that's separate to the automation layer. And there is a real good argument of why that's a good idea going forwards. But now we see, particularly in, you know, safety PLCs, the cost of safety PLCs have come right down in price. The functionality has increased, and it's about us as a nation really kind of dipping our toe into that and not being scared of the fact that we can put safety components onto networkable architectures. Now, in older machines, that causes a bit of a dilemma, because there's a cost element involved. But it may be that it's planned in as part of an overall upgrade of the control system. So if the machine's being upgraded, if it's an old machine, generally there's a new automation layer that's being put in there. So let's think about having that as a safety or a configurable or a safety automation layer, and then think about the benefits of having those devices that aren't connectable. You know, Ian mentioned about wireless safety. And I guess, Ian, one of the challenges is that we are very traditional in our approach and our way of thinking. And if we've got a physical cable connecting this bit to this bit, if it breaks, we're all happy because we've seen the cable break and we understand what the outcomes are. But when we're looking at no cable, it's should we do this? And is someone going to put the name to that? That's the other thing, you know. It's having that, I guess.
Yeah, I think you're right, Mark. I think it is a cultural thing. We do like to see something plugged in. I think sometimes, though, you manage to capture someone's imagination, you know, about Bluetooth and Wi-Fi at home. Not always a good thing, though. Sometimes, you know, because people get home and they can't get on the router because the kids are playing with their PlayStation, etc. You know, there's not enough spare bandwidth for you to see the news. I think really, because we're not in that kind of environment, and the link between is bespoke, that the type of structure and planning that you have for a network, even retrofitting old machines, has to be thought about and implemented pragmatically. You know.
Thank you. Luke, you've sat there patiently listening to comments on new and old machines and also on the wireless safety. What's your take on that?
Yeah, interesting, I suppose. I think the last 2 years, 18 months has actually solved some of our problems. So the shortage of supply has forced innovation in these machines. We've forced supply chain changes. To build the same machine, you might have to have switched vendor due to supply chain issues, or you might have had to simplify your machine. And that's where we're seeing through drives now, we have onboard functional safety on our drive with I/O and logic capabilities that can simplify the machine by removing safety relays that were previously used for safe talk off. We could even communicate to the controllers via these safe buses. The simplification there has allowed them to reduce their vendor set and then just worry about fewer components in their system. So I just think this last 18 months has actually forced out the hand of machine designers a little bit to make those changes. I like the idea of the wireless safety in that by removing the wire, you do actually have an inherent benefit. You know, the signal, as I said before, the signal now is digital, so we're not worried about whether it's a 1 or a 3. We know it's a 1 and we know it's a 3 if it gets there. I do think that we will have certain scenarios where, just down to pragmatic robustness, noise and possible interception, as you said before, Ian, with flooding of wireless signals, then you just end up with nuisance trips, and they can also be a safety hazard in their own right, because then we get used to going, okay, it's tripped again, it's reset, let's go, without actually fully investigating the source of that trip. But
you are right. We do a little go and have a look at the site first piece of kit with our broom handle with an aerial on the end.
And Ian, you pointed to the safety of the human inside the needing the e-stop, and we already know that there's issues with more chemical plants, I would say, but humans actually being close to something. So if that signal for the measurement can be moved wirelessly, then they're not exposed to that chemical. So there are safety benefits to that. And with the RFID, I find that really interesting. But I actually find at Control Techniques, we've recently used NFC on our drives, near field communication, getting sort of 10 centimeters proximity to the device. I think that's just waiting to happen. Safety needs that, because now we can start using NFC as a digital token to say, I am authorized to go and perform this action. Here, tap my phone, which has got my digital signature on, to authorize that action, or move more data than RFID can do on its own, because NFC with powered devices can cope with that demand. So I think there's some exciting road ahead with wireless, but I don't think it's applicable to all scenarios on the wider plant. I do worry, Ian. You said 800 meters transmit distance, and I can see the applications where you might want that, but I also know that there's a strong leaning in the non-safe world now for mesh networks where our transmit distance might only actually be 10 meters, and we're really relying upon many devices across the plant for our message to hop from hop to hop to hop, and that has its sort of security advantages in that nature.
Yeah, absolutely. I mean, the signals that go up to 800 meters in free air, and we wouldn't recommend any wireless safety without having first done a robust site investigation, and also the particular product in question has the ability to work in 3 different modes. So we have one-to-many. The signal gets there eventually, and stops within a certain amount of time. That's the kind of Ocado thing when you've got stuff whizzing all over the place, and when you press the stop button, they stop where they are. You have the kind of mesh network that you were talking about, where each of the receivers can then resend that signal on, effectively making their own mesh network, and one-to-one. And the one-to-one, I just did an ATV design for a customer where I said they could use one-to-one or one-to-many, and they decided actually on my user's platform, I would much rather have an e-stop for each ATV, so I know exactly what I'm stopping. So he chose individual one-to-ones for 5 ATVs. So he's got 5 stop buttons, you know. So really it's part of the design spec, the initial risk assessment for the requirement, and also implementation and what you see as a priority for your particular business. So yeah, I mean, yeah, I would like Dole to go to the next level, and what more can we do with wireless safety? And I bang my fists on the table in Germany when I go and see him. Show me the roadmap.
Can I just pick up one of the questions that's coming on the chat from C-Best?
I'm just coming on to that actually. So
Okay.
So this is a good time. I have a little voice in my ear that tells me you're dying to provide an answer. If you wouldn't mind, I'll go to oral first, and then I'll go to you second.
Sure, okay.
And the question was, how can end users introduce new technology and satisfy themselves that they are complying with the absolute duty associated with Regulation 11 of the PUA regulations? And it makes the point industry has had 20 odd years of conditioning to guard everything and stop everything. So I thought you might like to just comment on the issue of introducing new technology and the compliance issues that it involves, bearing in mind technology is obviously ahead of standards, isn't it? And that's one of the challenges we face. So Oral, if you are happy to comment on that, and then I'll go to Mark.
Well, I don't think that new technology necessarily conflicts with the regulation, so it's still valid that we have to protect the system. So I mean, if the design is not intrinsically safe, we have to guard people from getting into the unsafe area with light curtain, stuff like that. What I would like to bring into the discussion is something that an emerging trend in automation that we right now see, and it's underlined by one or the other standard that is even emerging right now. One is called MTP, module type package, that we see in process automation and pharmaceuticals, which is emerging, is decentralized intelligence. And that somehow relates to this, because we're focusing on decentralized intelligence. So we have devices that can be controlled by the central PLC through Profinet, ProfiSafe for safety devices, but we have decentralized intelligence as well. So you can run on our IP67 on-machine block IOs, and Mark brought the point that on-machine safety is really interesting. Run your own safety logic directly where the action happens. And that has 2 aspects. One is less latency. Less latency means the guard distances can be shorter. So you can have your machine space decreased, smaller machine space, because you don't need such a huge guarding zone. And the other aspect is this system even continues to run if the other parts of the systems are compromised. So if for instance, the PLC is turning off, the decentralized intelligence in the field, even containing safety logic, is still running. And that's a topic for safety and non-safety, because that's another dimension of networks that we will potentially see in the future. There's a trend which is just about to start, to offload intelligence from centralized PLCs to distributed systems and making small components smart, which is, let's say, foundational infrastructure for adding digital services to subsystems as well. And at the same time, that is part of a separation that makes compromising complete systems more difficult and adds to a certain extent security to those systems. I hope I didn't crash the complete answer on his question, but I guess it's even possible. So we can make the guard zone smaller by using new technology while still complying with the requirement, which is very old. And I added a few more, let's say, dimensions to this conversation. I hope that's fine.
Thank you very much. And actually, it was a real curveball, because I should have said the work equipment directive for Germany, as of course you don't have the PUA regulations in Germany anyway. Mark, back to the central theme there. I know you're very keen to answer that.
Yeah. So Colin, CBEST, thank you for the question regarding PUA. And if you look at PUA, the provisional use of work equipment regulations, and Regulation 11, there is a clear hierarchy of measures that employers should take, and providing fixed guards is very high in that hierarchical list, and quite rightly so, because part of the risk assessment, unless you can inherently change the design, then you need to put those measures in place. So absolutely put those fixed guards in, and I don't think anything will replace putting a fixed guard around something that's potentially going to cause harm. What we're seeing is that the technology that's been historically used, such as lockout tagout, has been not glibly put in place, but incorrectly put in place and not considered around the actual type of intervention that's needed on that machine. So if you make something far too difficult and cumbersome, people will defeat it. They'll try and get a workaround. They'll take the shortest path and least resistance. So what we see is absolutely with those guards, and we should stop everything, we should put those guards in place. But why have a really cumbersome system when you only need to stop the machine for a few minutes just to straighten the board up or wipe a roller down, but you need to do that safely. And if it's production, the pressure of production on people is immense, and it does take over, and it makes people make potentially irrational decisions when it comes to operating machines and doing that safely. So, let's take that out of the hands of the operator and give them, really agile technology, such as, this kind of I don't know if you can see that, but RFID key in pocket access control that can be utilized in conjunction with other safety systems and fixed guards, but to do that quickly and safely. So we just see this kind of, misuse of the technology, really. So I hope that answers Mr. or CBEST's question around Regulation 11 of PUA.
Thank you very much, Mark. We're coming towards the end of our time. So just to point out, if anyone on the call or in fact watching this on demand after the call has any further questions, there are ways of getting in touch with our experts. The best one of which is to log into the Talking Industry LinkedIn page, where we can invite our speakers to continue any discussions with registrants or indeed non-registrants about the topics that we've discussed or anything else that they want to cover. We've just put in also the link to our Talking Industry website. So there's lots of ways of getting in touch and asking further questions, and we do encourage you to do that. There's a fantastic amount of information that's been put into the chat as well by our speakers, and we'll make sure that all of that is passed to everybody on the call and everybody who attends our on-demand version as well. And of course, now last question has come in. Well, never mind. Of course, we are, as we said before, we also run this as a podcast now, so that you can even listen to us in the car. So lots of ways of keeping in touch, and that's the whole point of it, is to encourage interaction and communication, which I think has been excellent with our four speakers this morning. So we have a little question here which I will cover. It's probably one for Ian, and then what we'll do is we'll just circulate and say, what does each of our speakers think is the next big thing in safety and security, and then we'll close after that. So a bit of time to think of that. Question really for Ian though, can wireless safety achieve the same levels of safety as conventional wired safety?
Simply yes. So PLE, Cat 4, SIL level 3 houses. So providing it's designed in the right way and implemented correctly, then yes.
Great. Well, that's a nice quick answer. And Rob, if you want any more details, obviously you can contact Ian outside the call, and we'll make that easy for you. So while you're on, what's the next big thing in safety and security, Ian?
There's been some interesting noises around the RFID. So I've heard a lot of that. There's also been some interesting noise around secure Bluetooth, two-way. I think really I would like to see something in the standards that copes with the smaller business who haven't necessarily got the kind of infrastructure that the larger companies have got. I mean, ideally, you'd want to be able to throw everything over 5G secure Ethernet, but I think that is too much of an ask, really.
Thank you.
So I'd like an equivalent.
What would your answer be, Luke, to the next big thing?
Yeah, I mean, I think we're going to see a push by governments on certain machinery applications demanding standards for cybersecurity, which will then enforce that push all the way down to the vendors. But my hope, honestly, is that we can find this happy medium where vendors can be fixing the holes in their system, providing updates which are secure, and that we can get to a nice point where machine manufacturers or operators have a process in place to take them, verify them, and move on. Because unless we do that, then our systems aren't going to be safe anymore.
They're more process than technology in many
exactly
ways.
Yeah, I said it's the human that's the problem. Let's solve it.
Yeah, lovely. Okay, Mark, your comment?
Yeah, so for me, it's kind of one clear message, and that's networking. I think that will only go in one direction, and that is forwards. So today we see a real drive towards a product that we have, which is a gate box, multifunctional gate box on comms. It's all in one area. Everything, push buttons, access control, locking, unlocking is done in one area, and that's networked back at the PLC. So the benefit there is that your safety system is all in one space. The verification and validation is made a lot simpler. And the benefits of that going forwards from the data point of view, knowing what's going on, where and why and how, are really crucial to making processes more efficient and, hopefully stopping the need for these shorter term interventions that cause people harm.
Thank you very much. And it comes round to you, Oral, for the final word, final comment.
Yeah, I'm not sure if it's just one big next thing. I think it's a constant process, an iterational progress of improving the systems, and networking, of course, is a thing. I think a big step was the integration of safety and non-safety, and this integration will continue. So namely ProfiSafe, SIP safety running on the same network. That will continue to trend. Definitely IO-Link safety will be a topic, and maybe in combination with wireless. So then we will have another wireless safety system, which is excellent. Along the way, those systems will have to face security, including safety and non-safe signals. So that will be another part of the integration, and that will definitely come. The 62443 will be applied much wider and requested from customers. And ultimately, I brought that up, and that is something that drives many of our design decisions for years, is decentralized automation with decentralized intelligence, smart subcomponents integrated into larger systems, orchestrate instead of program everything through integrators. And that combines safety, security, and paves the way. In addition to that, paves the way for digital services of the future. And that is what we see coming. Not to mention single pay Ethernet in between, so which will bring Ethernet down to even the lowest levels on the shop floor. So that will potentially enable further devices to add industrial Ethernet and safety to sensors and actuators.
Which clearly means that there's a whole big discussion that we've only scratched the surface of. So
I think so.
do feel free to come onto our LinkedIn pages and continue that. We have been asked if the webinar is pushed out as a recording, and yes, everyone who's attended today and everyone who even registered but hasn't attended will receive that as well. So lots of ways of continuing the discussion. But for now, I'd like to thank everyone who's registered on and attended for your time. I hope you found it worthwhile and interesting. Certainly, some of the comments in the chat suggest that's the case. And particularly, I'd like to thank Ian, Oral, Luke, and Mark for their excellent contributions and their interactions during the last hour and a half or so. So thank you very much indeed. And we'll look forward to seeing you again very shortly for the next Talking Industry. Thank you very much.
Pleasure. Thank you.
Thanks.
Thanks as well. Have a great day.